Python is a widely used programming language with a strong community that's been around for over 30 years. This community creates extensive libraries for almost any application, including scientific computing and AI. It's used for software development, scientific analysis, automation, and geospatial analysis. Python has been integrated with ArcGIS for over 20 years. They're used together by developers like you. And here's how. On the left, we have ArcGIS providing two primary Python libraries. ArcPy, giving you access to over 2,000 geoprocessing tool functions for data management and spatial analysis and mapping and much more. And the ArcGIS API for Python for automating GIS workflows and incorporating GeoAI models, as well as interaction with open data science tools like Pandas and NumPy through a spatially enabled data frame. On the right, we have the experiences for working with these libraries and writing Python code. You can work in ArcGIS notebooks, in Enterprise, in Online, and Pro, and in Pro's Python window, which also has built-in libraries and is customizable in many different ways. You can use the IDE of your choice for developing these web tools and geoprocessing services. And ArcGIS enables big data workflows with PySpark and the Geoanalytics engine for integrating open source Python for advanced GIS and data science workflows when both of them have to be used together. So rather than me talk about it, I'd like to introduce Kimberly and Nene to walk us through some exciting new features of ArcGIS Python.
Thanks, Jim. I'm going to show you some highly anticipated productivity enhancements coming to ArcPy and Python with ArcGIS Pro. Here in the ArcGIS Pro Package Manager, if we previously wanted to create a clone of the default environment, it would use a local package cache located in the local app data folder. However, if this was your first time cloning the default environment, it would need to download this package cache from the internet. In the latest version of ArcGIS Pro, we are now introducing copy-based cloning. This new offline cloning method will be the default method to clone environments. But of course, if you would like to use the previous online cloning method, it is still available from the context menu. So let's create a clone with this new offline method. And if we just take a look at the messages in the task, just give it a moment. We can scroll to the top and see that it is using our new Conda Pro clone call. This custom call will give disconnected environments the ability to create custom Python environments. So now let's take a look at the default Python environment. If you work with raster data, you're probably familiar with the GDAL package for its analytics and processing. We now include the full distribution of GDAL out of the box, so you can easily use those command line tools, such as GDAL Translate, to convert your raster data, with only using the default environment or any custom clones that you create from it. Many of you have also asked us for better pathlib support for its string concatenation and all the benefits that come from object-oriented paths. So we have integrated pathlib into ArcPy. What I mean by this is all geoprocessing tools and ArcPy functions that take paths as input can now use pathlib paths. We've also created an environment variable that, when set to true, will enable all geoprocessing tools and functions that return paths to now return them as pathlib paths instead of strings. So take ArcPy DA walk, for example. We can now use pathlib paths as input, receive a pathlib path as output, and use the simplified concatenation operator. Pathlib paths will also give your ArcPy scripts better cross-platform compatibility. Now, let's go take a look at Visual Studio Code, where we have the ArcGIS Pro debugger, where we've made a few improvements. We now have a brand new ArcGIS Toolbox Explorer, which will open in the side pane, where you can view all toolboxes that are located in whichever folder you've opened in Visual Studio Code. You can see the toolbox name, the number of tools, and the type of toolbox. And when you expand the toolbox view, you can even view the code for your tools that are contained within it, even if the script is embedded. You can also create new Python toolboxes, give it a name, and choose from 3 different templates. Minimal for just a basic, quick start for your toolbox. Basic for a single tool with a few parameters. Or advanced with multiple tools, multiple parameters, ready for you to customize to your needs. The ArcGIS Toolbox Explorer also gives better navigation to Python toolboxes. You can easily jump between your code for the different tools contained within it. Another feature that we have added to the ArcGIS Pro debugger is ArcPy snippets. So if we open the debugger menu, we can see Insert ArcPy Snippet, where you have a few default choices of code to insert into your ArcPy scripts. And if you have a block of code that you use often across many of your scripts, you can even save them as your own custom snippet. And if you'd like to help the Python community, you can even contribute snippets to the ArcPy GitHub. Another highly requested feature is the ability to create ArcGIS Pro projects using Python. This is now a possibility with ArcPy NP Create ArcGIS Project. All you need is a project folder path, a project name, and you can create a brand new project. From here, you can even create a map and add layers to it, all without ever having to open ArcGIS Pro. These are just a handful of the new enhancements that we've added to the latest version of ArcGIS Pro. Thank you, and I'll pass it over to Nene to tell you about some exciting capabilities in the ArcGIS API for Python.
Thanks, Kimberly. Today, I'll show how scripting with the ArcGIS API for Python enables developers to enhance and evolve applications and operational data. We'll go through 2 examples. First, how to maintain consistent field app form configuration at scale. And second, how we can enhance operational data using the new AI utility services. We'll start with a mapping workflow, but the goal here isn't visualization, it's consistency. We're working with controlled burn operations in the lower Sierra Nevada. Each burn area has its own operational web map, different crews, different locations, but the same data schema. This means field app users want the same editing experience no matter which map they're working with. Here we see a form configured by our field operations team. It holds information for burn areas, leadership assignments, go-no-go logic, and more. Behind the scenes, Arcade works to control visibility and interactions based on the field user and scenario. My other web maps don't have this form configured yet. Manually reconstructing this form for all of my burn area web maps could be time-consuming and lead to some inconsistencies. So I'm going to automate it. I'll run the cell and we can walk through it. I start by grabbing the web map where that form is configured, the one that we just saw. I then list the target web maps that I want the form to be applied to. Using the Python API mapping classes, I can extract the form information and then apply it to each of my web maps, even updating the expression information if needed. Once this is run, we can go back and reload, and we'll see that in the field map designer, the form has been perfectly replicated. There we go. Oh, it didn't load well. There we go. OK. So what we did was we defined the form once, and we applied it wherever it was needed. This transforms manual setup into repeatable governance. So now we're going to switch gears from configuration to operational data. Using the new ArcGIS AI Utility Services, now in beta, we can integrate text intelligence and image analysis directly into our GIS workflows. We're going to see an example of this using the Open 311 service requests in San Francisco. If I look at a feature, I see the user request, the submitted data, and an image that has been submitted with each of these requests. The goal is simple. Use AI Utility Services to extract information from our dataset. We'll start with the images. We're going to define a prompt asking for a caption, tags, severity, and usability to be returned for each of the images. I'll pass the image URLs along with that prompt to the Analyze Image method. The output is taken and written directly back into our feature layer under New Fields. Next, we're going to take a look at the request descriptions. Here, we'll ask for a summary and a priority score to be generated for each of the request descriptions. This gets passed to the Analyze Text method, and the results are once again taken and written directly back into my feature layer under New Fields. Finally, we'll translate those new summaries. In regions such as the Bay Area, multilingual access to public information is critical. So we're going to use the translate method to translate to Spanish and simplified Chinese. Once all of this is run, we can take a look at one of our features to ensure that the data is there along with the new fields, and we can visualize the results. I now see the results rendered by priority. Clicking on one of these features, I get a better sense of what the case is, who to contact. We see the summaries that were generated along with the translations and the image analysis results. By integrating AI Utility Services directly into the GIS workflow, we were able to transform raw user input into informational GIS data, all within a single script. Today, you saw how the Python API gives control over the user experience and the data behind it in a way that is scalable and intelligent. Back to you, Jim.
Thanks, Danae. And thanks, Kimberly, for showing us some really cool ways where the ArcGIS API for Python and Python and Pro is being used. We continue to make a lot of investment in the integration between Python and ArcGIS so that you can build awesome apps and it can improve your productivity.